You are sitting in a coffee shop with someone special. When your hot cup of coffee arrives, you touch the cup, it's too hot. So you give it a little blow, and tada, it cools down just enough to drink. You smile, almost like a magician, and take a sip. But you never stop to wonder what magic you actually performed. How did your coffee cool down? What did your breath actually do? Where did all that heat go? You just blew some of the heat away and lowered its temperature. But wait, heat and temperature, aren't they the same thing? Let's find out. Let's start with what you felt when you touched that cup. That feeling of hotness. That's what we call temperature. Temperature is a relative measure. It tells us how hot or cold something feels. A hot utensil simply means it has a higher temperature, while an ice cube has a lower temperature. We should note again that hot and cold are relative terms, kind of like tall and short. Someone can be taller than you, but still shorter than someone else. Same with the temperature. Your coffee is hotter than ice, but next to molten lava, it's practically chilled. We can perceive temperature by touch, but estimating the temperature of any substance, how hot or how cold it is, by touching is very unreliable and very limited. You can't just dip your hand in lava and declare, yep, this must be 850 degrees Celsius. Also, all ice is cold to us. That's why scientists needed a clearer, more reliable way to describe temperature. So they looked deeper and found that everything, the coffee cup, the table, the air, even you, is made up of tiny particles called atoms and molecules. These particles are always in motion. Sometimes they vibrate in place, they rotate, and sometimes they move around freely. Scientists noticed when the particles are moving really fast, we feel the object as hot and say it has a high temperature. When the particles are moving slowly, we sense it as cold and say it has a low temperature. So, temperature is simply a measure of how fast, on average, those particles are moving. And how do scientists measure that? We will save that story for another video. For now, let's come back to where we were. Right, sitting with that cup of coffee. When the coffee was hot, its particles were moving very fast. But when you blew over it, the coffee cooled down. So, what really happened? Why did coffee particles begin moving slow afterwards? Where did all their energy go? Here is the secret behind your magic. When you blew on the coffee, the hot coffee comes in the contact with your relatively cool air. The fast moving particles in the hot coffee pass some of their energy to the slower moving particles in the cooler air by literally colliding with them. As a result, the coffee cools down and the air around it warms up. That flow of energy from a hot object to a cooler one is what we call heat. Heat is not something an object has, it's energy in motion. It's the transfer itself. So, temperature is how fast the particles in something are moving, while heat is energy that flows from a place of higher temperature to a place with a lower temperature. This simple rule governs our world. It's the reason why your cold drink slowly warms up when you leave it on the table. It's cooler than the surrounding air, so it gains heat from it and its temperature rises. Similarly, a hot cup of tea cools down because it has a higher temperature than its surroundings, It loses heat to the air around it, and the tea becomes cool. An ice cube melts because it gains heat from the surrounding air. The added energy makes its particles move faster until the ice turns into the water. Food heats up in a microwave because it absorbs energy from the microwave radiation. Air conditioners cool a room by removing heat from the air inside and releasing it outside. Even a metal spoon left in a cup of hot tea becomes warm as it gains heat from the tea. The same thing happens on a larger scale. The earth gains heat from the sun during the day and loses it to the cool night sky after sunset. That's why days are warmer and nights are cooler. Temperature is usually measured in the unit you see most often, degrees Celsius. On this scale, 0 degree is the point where water freezes into ice, and 100 degrees centigrade is where it boils. But scientists often use another scale called Kelvin. It starts from a point called absolute zero, the coldest temperature possible, where particle motion completely stops. That's at minus 273.15 degrees Celsius. And what about heat? Since it's a form of energy, which is in motion, we measure it using the standard unit for energy, the joule. In earlier times, people used another unit called calorie. It's still used today, especially when we talk about the energy in food. Like when a chocolate bar says 250 calories, that's really telling you how much heat energy your body gets from it. Temperature is measured using a thermometer and heat with a calorimeter. But how exactly do these instruments capture something we can't even see? Let's save that mystery for the next video, where we will explore how scientists learn to measure this invisible thing we call temperature. Until then, maybe take another sip of your coffee before it loses a little more heat. If you like this video, share it with someone who loves coffee or science or both. And tell me in the comments what's the coolest or hottest thing you have ever experienced.